Hi everyone. I hope that you, your families, and your communities are all doing great at this time. Thank you for joining MIGS this year and joining this session in particular. So today we're going to talk about bridging traditional game development with cloud workflows. So before we actually dig into it, I'm a big dreamer and I'd like for all of us to share a dream. Basically, let's dream together that AAA games will be accessible to everyone using only battery-powered devices through the internet. Oh wait, that's already happening, right? So what could be the next big dream? Well, it could be that we build those games using the same ID, only battery-powered devices, no big infrastructure, very something that is easy to access and that lets us build games, executables, cook data in matter of seconds instead of hours. That could be an interesting dream. But where are we now as an industry? Right now, major players that were previously outside of the game industry recently joined and they announced their own game streaming platform. On the other end of this industry, studios are all embracing cloud computing, whether it's for game as a service or to host their game servers or even to build new pipelines on the cloud. Yet, many engines, pipelines, and workflows we have built have been built with on-prem hardware and on-prem workflows, and we still focus a lot on it. So where are we heading then? Given that dream and that state, we might be heading to cloud-native games engine and pipelines. At least that's what I dream of. So I'm Gabe. I joined Stadia Games and Entertainment late into 2019. Before that, I worked at Ubisoft, Splash Damage, and other companies. I also tried my own company outside of games too. I'm a technical architect, which is a nice way to say I'm a software engineer. I like combat sports and cats, and I worked on different types of games, from sports to open worlds to first-person shooters, through online games with cloud, without cloud. So before we dig into the challenges that we're going to face to bridge our workflows to cloud-native workflows, we have to define what cloud-native is. And Wikipedia can help us defining cloud-native computing as an approach in software development that utilizes cloud computing to build, run scalable applications in modern dynamic environment such as public, private, and hybrid cloud. That's a mouthful. We have to start by defining what cloud computing is and what are those dynamic environments. Cloud computing is the on-demand usage of computer system resources. Basically, your CPU, your RAM, your GPU, storage and networks can be extended. You ask them on demand, you get them, and you can release them with high flexibility. But cloud computing is also about managed services with high availability. You don't have to care how to run your next Mongo stack. You can just deploy it and trust that a lot of the infrastructure will be taken off your shoulders. That definition also brings scalable applications in the picture. And when we talk about cloud, a lot of us think about horizontal scaling. Oh, that's cool. We're going to add more machines or more processes to solve the problem and serve a bigger population. Well, I would like to also point out that vertical scaling that we all experience, either when we changed our on-premise hardware to get new SSDs or bigger CPUs, or when we changed console generation. Like vertical scaling happened at that point, we know about it. But in the cloud, vertical scaling has different limits. Way more CPU than what you're used to, and more RAM that you're used to as well. Before we continue on what cloud is and what it brings, I would like to picture it for game developers. We've been used to do some things for a long time, But cloud isn't that different from what we've been doing. Remember the transition a couple of years ago to multi-core architectures? The transition to the PS3 where we used the PPU to send off some data to SPUs so that those SPUs could do compute and send back results. Well, cloud computing is pretty close to that, right? You're going to send data off. That data is going to land somewhere. It's going to be computed by something, and the results are flowing back either to your game servers or to your workstations. So we already done that. The other important aspect that game developers tend to care about is storage. When we build games, we try to optimize our access patterns for data, and that shows in our workflows on our day-to-day pipelines. We think about registers, we think about CPU caches, we think about RAM, and this extends all the way to local storage. Tool programmers might add to that on-premise storage, network-attached storage to distribute builds, maybe even on-premise cloud storage. Well, moving to cloud, we're going to deepen that stack. We're going to add to that edge storage, like the one that is used for cloud delivery networks, as well as cloud storage, the one that is used in data centers. Game developers tend to talk about access speed, and with that comes storage scarcity. Basically, the faster you go, the more expensive it is, so the less you have. Well, in cloud, we tend to talk about latency and storage size, and you basically have to reverse that stack. Easy, we know about all of that. So what does the cloud look like? I introduced two concepts, cloud storage and edge storage. So let me talk about what it looks like in reality. A lot of people think that you basically have your device, it's connected to your ISP, and that's it. You're connected to thousands of data centers. It's not exactly true. From the point of view of our workflows, you usually have your device that is connected on-premise to your networks. That on-premise architecture might have a private cloud with some on-premise storage or build machines on-premise compute. It's connected to a gateway, and that gateway is connecting you to your ISP. Your ISP has a presence in an internet point of presence or an internet exchange point. Usually, it's a building where several companies are co-locating hardware. That way, your ISP can talk to other ISPs or other companies such as Google, Amazon, or any CDN company. In that point of presence, we have edge compute and CDN caches, so edge storage. It is not cheap, but it is close to your users. And then that point of storage is connected through ultra-fast networks to data centers. And at that point in data centers, compute and storage becomes widely available, and communication is very fast within zones, within the data centers, and up to your point of presence. Basically, the slow link is most probably between you and that point of presence. So let me walk back a second and talk about what we're solving again. Many games are moving toward game as a service. We're adopting cloud-native workflows because it helps us build and push content faster to our users. But cloud doesn't offer just that. It also helps companies with managing on-premise computer resources. That is complex. So cloud can help you by taking off your shoulder that managed infrastructure. Ideally, you can focus on your product. The last point I want to bring is resource scalability. It is really interesting to see that when we need more build machines, it is actually complex to get that when you're on-premise. It's because you have to go buy them, set up them, add them, and basically if you don't need them the next month, well, they're still there, you paid for it. So cloud, if you need to produce a build faster, well, you can commit more resources to it, a bigger machine. If you want to produce multiple builds in parallel, you can commit multiple machines to it. But if you're done with your workflows, well, you can decommit that. You can release your resources and stop paying for them. To me, that is accessibility, that is flexibility, and those two advantages are super interesting from a pipeline point of view. So now let's talk a bit about the challenges of moving our workflows from on-premise to cloud. But before that, I have to confess about something. Before working with cloud, I didn't have to care about too many things. I honestly had it easy. Latency and bandwidth consideration only happened for when I was working on low-level engine tasks, or maybe rendering tasks or network tasks, but not necessarily when working on tools or distributing builds. Identity and access management, I wasn't involved in that. That's for security experts, right? Data coherency and consistency, I only thought of that when I was thinking about cache coherency, but not really at scale. Service deployment, I got a fair share of that, mostly outside of game, but I know that all you guys working on game as a service are taking the road to learning that. We have to roll new versions out, but we have to roll them back too. We have to have processes for that. And embracing microservices, it's interesting in terms of deployment, stability, availability, but with that comes debugging distributed applications. That's something new for me. Monitoring those applications and encryption as well isn't something I used to think about as a game programmer. But as a cloud programmer, I do need to think about that. So let's dig into our first challenge, the data. Game pipelines generate and treat a lot of data. Some engines are actually pretty bad at identifying their inputs and their outputs. So the first challenge is, well, let's move all of it to the cloud. Well, moving data into the cloud can take time. You probably don't want to upload everything. And moving them out of the cloud can be costly. So on top of that, if you add caches or on-demand requests to your data, then maybe the cloud will add latency to that. So it's all a few steps of problems that we're going to go through, but the resolution is fairly easy. Basically, when you design a system, plan for data consistency and coherency. Basically, what are your users seeing at time t, and how is the data set coherent at every step in your pipeline. Avoid designing systems that continuously require to push tons of data outside of cloud. Basically, push only data and embrace laziness, embrace on-demand access. The good thing about that is that's something we already do in games, usually on game engines. We try to prefetch the latency critical bits. We tend to do clever paging and caching of the important data, and we only touch what we must. So let's apply that to data in the cloud. It works fairly well. The challenges number 2 is once you get your data in, well, you're going to run executables over there. But if you look at the landscape of cloud computing, it drastically changed from a few years ago. Back in the days, there were only VMs, and you would set up your Linux machine and then you would do whatever you need to do to run your executables. Nowadays, you have VMs, you have container engines such as Docker with its orchestrator, Kubernetes. You have fully managed stacks like App Engine Flex, and you can choose between a variety of options. Being sole tenant on your machine, so no one else can run workloads on your machines, or multi-tenant nodes where basically you share those resources with other companies. You might have to think about networks, cloud networks. So Really, the resolution about that is to think about your workloads. Not all of them are created equal. So what is the best stack for each workload? If you're building a web page, maybe you don't need to run that on one VM. Maybe you can use something that offload some of the infrastructure from your shoulders. So you need to define the flexibility you need and the customization level you need from your stack. With this comes how much time you're willing to spend on that technology. And again, we should take the road that lets us focus on our product. We're making games, not infrastructure. Changes number 3 is I'm running a service in the cloud. I put some data over there. I solved my last 2 changes. So now I need to present that to some users. Well, that's easy, right? We're in the cloud, so let's build a web UI. Well, not so quick. I often hear, let's build web tools for everything, which to me sounds like, let's throw away what we have and redo everything. Well, don't do this. Never throw away everything, not everything. Web isn't easy. It's definitively not easier than your common application. Don't underestimate web. It's a deep tech stack that you have to learn. So you have to ask about web, what does it bring? And what added value does it bring to your users? Only use web when and where it makes sense. For the rest, use APIs and endpoints that allows your original applications to do remote procedure calls into your service. Cloud isn't web. Web uses cloud, but not the other way around. If you're interested in APIs, look into gRPC, cloud endpoints, and Kubernetes services and ingress. It's really interesting. It is a good step forward to be utilizing cloud compute without having to redo all the user interface. Change 4 is, I have my service running, everything's fine, right? Well, picture for a second your bug database. Picture that without the ability to inspect logs, get call stacks, reproduce a bug locally, or even know that there is a bug happening. Well, that's scary, right? Software and hardware fail all the time. So the next step is, because you're running workloads remotely, you need to have signals about, is it healthy? Is it working? So you're going to have to monitor your applications. That's your second step. Once you get your workloads in, second step is to start monitoring. You gather metrics, you define alerts, and you define playbooks fairly early on for when those alerts will be triggered. It is important that the person who operates your service knows what to do when things fail, and they will. So for that, I would say you can look into cloud monitoring, but if you're more on the open source side of things and using Kubernetes, you might be looking at Prometheus and Grafana. Next is security and access control. That's the part where it starts to get interesting. If you expose something to the internet, well, guess what? Somebody is going to try to gain privileged access. Somebody is going to try to exploit that, or at least toy with it. You don't want to have anyone toy with your running services. Anything you expose to the public internet grows an attack surface, and you should treat that carefully. So as much as you can, use private IPs. Don't expose things to the public internet. To do that, you can use NAT and gateways, VPNs. If you are using clouds and virtual private clouds, you can probably pair them together to avoid exposing anything to unwanted users. Protect your traffic with firewalls. Ideally, use distributed firewalls that can protect at the VM level. All your endpoints should do authentication and authorization. Don't trust that because someone gained access to one endpoint, then it has access to everything else. Each endpoint should do its own authentication and authorization. The last two points are about privileged workloads. If you're in the Kubernetes world, most of the examples you'll see are actually running your containers as root, so with privileges. You should try to avoid that. Look into pod security policies that can help you define that at a cluster level and make sure that your pods are actually secured. Finally, encrypt what you can. It is important not to trust that nobody's sniffing information out there. Most likely there is somebody trying to actually gain access to what you have. So take security treat that as an important matter. And when I joined Google, I want to share that I discovered the Beyond Corp model. I engage everyone to look into this if you're interested in security. It's basically building a zero trust network. It is very interesting. Change number 6 happens when you're deploying new application versions and new features. Okay, we have our workflows, our data, everything secured. Thumbs up, we're running in the cloud. We need to deploy the next version. Seriously, what could go wrong? Each time I submit something, that's what I ask myself. So because everything can go wrong when you deploy a new version, there's a few things you should put in place to avoid things to be wrong and too bad, have too much impact. First thing first, embrace infrastructure as code. You don't want to be clicking on UIs to set up your infrastructure. It is very error prone and it is not reproducible. So embrace automated processes, and that goes to your rollout and rollback processes. Those should be automated. You should be checking in configurations, and a tool should pick up that and actuate your clusters. Define your signals for a healthy rollout so that if that signal is bad, the rollback can be automated if possible, or at least you could be alerted that something bad is actually happening to your users. Never roll out versions to the entire population at a time. I used to do that when I was deploying the editor build every morning to everyone. Sometimes it resulted in everyone not being able to work. That's probably bad. So even though you have testers probably in place to catch this early on, an actual way of working in the cloud is to roll out progressively to your users a new version. Finally, I want to talk about dynamic feature switches. So we can roll out new executables, we can roll out new data, but that takes time. And because it takes time, it is an involved process. What if we could turn on and off features dynamically through configs? That's very easy to build, right? As engineers, it's a matter of an if statement. This is a very good way to enable and disable features. You should, if you can, embrace that. But if you do embrace that, make sure you can trace both the versions and which features were actually enabled at a time in your logs or in your crash dumps. This is very important when you will be debugging a specific version of a crash to understand which version and which combination of flag were on at a certain point. So make sure you can trace that. Change number 7, and the last one for today, is debugging. Everything's running smoothly. I have monitoring in place. I can know what features are in and what versions are running. But I soon realized that attaching a debugger to a production environment is complex if it is allowed. Often it's not. If you embrace microservices, what is going to happen is you're going to have states that are distributed across many processes. One of them might fail, but when you're going to look at the crash or at the log of that specific application, you might not have the full story about what was happening. So you have kind of distributed states. So it is important that you log everything. Make sure you have a lot of information, it is better to have more information and not use it than not to have that information available when you need it. Try to correlate your logs based on application IDs, maybe remote procedure call IDs, or session IDs if it's a session-based workload that you're running. Try to embrace unit testing. I know this has been a long rant about unit testing in the past decade in games, but it is better to catch bugs sooner rather than later. Fuzzing your APIs can help as well, and basically do load testing. You're running in the cloud, you want to service a given population, make sure you can. Another thing is, don't be shy. Create custom tooling that could help you catch bugs sooner or fix them faster. So analyze what takes time in your workflows and create custom tooling to be more secure and more confident about how you fix bugs in production. When all things fail, embrace forensic debugging. Make sure you have enough data in your logs, in your databases, in your crash dumps, so that you might not need to repro a bug. It is actually better to be able to write a unit test and fix that with confidence than to try a repro that only happens one time out of 1,000 in production servers only. So in conclusion, I hope I didn't scare you. There are a lot of changes coming your way with the adoption of cloud, but we've seen that the game industry as a whole is embracing this new opportunity. Whether that's through game servers or through new pipelines and engines, it's coming our way. We are gaining new flexibility in resources. We are gaining new ways of working. We are getting there. But with those opportunities are coming new changes, whether that's latency and bandwidth. A lot of platforms we have to find the best from and choose the best for our workflows, running healthy services and monitoring them, managing deployments and enabling features, and checking that stability is always good. So you might know the saying about you can teach an old dog new tricks. I think that's false. That we old dogs in the game industry should learn new tricks from the cloud industry. This is definitively something that I'm super excited about, and I think it's a very exciting time to be in this industry. So with that, I thank you. Thanks for your time. I hope you're enjoying Migs, and I'm available for Q&A.